Hey everyone, this is Daniel for Rock the JVM, and in this video I'm going to show you how you can build a full-stack web application in Scala with the ZIO stack. So recently, one of my experienced students, Olivier Nouguier, just wrote a blog post on the Rock the JVM blog on how to build a ZIO full-stack web application after he completed one of my biggest courses on Rock the JVM, which is called the ZIO Rite of Passage. Now, in the ZIO Rite of Passage, we build a full-stack product with Scala 3 and the ZIO stack. So from scratch, we build a web application which contains all the bells and whistles that you would expect from a startup, including credit card checkout, user management, email integration, AI integration, nice design, and everything that you would expect from a full-blown product. We spent almost 40 hours of coding in this course, and after completing this application, Olivier stripped down the application that he wrote, and he just kept only the essential parts that you would need to build your own full-stack product with the ZIO stack. And in this video, I'm going to attempt to explain what the application contains, what the constituent parts of the application are, how you can get started, and some dev tips. So I'm going to get started with Olivier's template from scratch, as he did in this blog post. So we have an SBT G8 template that we can use. So I'm going to start a little terminal here, and I'm going to run the exact command SBT new, and I'm going to start from his own template. And then I'm going to navigate to that thing, so ZIO Laminar demo, and then I'm going to say code dot. So I'm going to spin up Visual Studio Code, and that's because when this project starts from the first time, some tasks are going to run automatically. For example, we're going to import some NPM dependencies. So let me make this a little bigger so that you can see what I'm doing here. So we're going to run some automatic tasks to import some NPM dependencies for Frontend and the SBT dependencies for the backend, and also start with some terminals automatically. So running the backend, running the Docker on the Postgres database that we're going to use for the application. We're going to compile the front end, and also we're going to serve the JavaScript that Scala.js compiles to with an NPM Vite. So we're going to spin up a local server, and Vite created this little thing, localhost 5173, which is the front end that we're going to use for this demonstration. So from a single command, we already have a dev environment fully set up and ready for us to design and improve. So if I navigate to this application, this is the web app that Olivier prepared for us. Obviously, for your own product, you're probably going to replace this. And this is the stack that the application contains. For example, we have ZIO, we have Laminar on the front end, and then we have the regular HTML, JavaScript, and everything else. Okay, now most of the functionality of this ZIO Laminar demo is on the login front. So if I zoom into this application, you're going to see here sign in or sign out. So sign in, you have a login and password. You can say sign up, and you have a little form to declare who you are. So Daniel, maybe Daniel at rockthejvm.com. Password is obviously rockthejvm, and age is 42, of course. Pet, you're going to create either a cat or a dog. You can select dog here. Name, you're going to say, age 3 or 4, and then you can create this person. So you say create, and this just created a user with these details. And this little toggle is the data structure that the Scala backend is going to give back to you. So this is the case class that we're going to map in the code. We're going to see that shortly. And then you can sign in as this user, like Daniel at rockthejvm.com, rockthejvm, and then log in, and then you're logged in. And then you have settings for your user, and you can toggle your pet to be visible or not, and things of that sort. So pretty much just user management, and you can add different pages on the front end as we will explore shortly. So let me show you the code. First, the dev environment contains some tasks. So if you go to VS Code, you have settings and tasks. These tasks were defined by Olivier. So we have demo or setup or Docker or run demo. If by any chance one of these tasks does not run, so if one of these terminals gets killed for whatever reason, you can call the run demo tasks by hitting Command-Shift-P or Control-Shift-P. Go ahead and say run task, and then run the run demo task, and this will start the same terminals one more time, including the Docker with the Postgres database, the server backend, which will start just the backend project, the fastlink, which is going to start the Scala.js compiler to JavaScript, and npm, which will serve the resulting JavaScript as a local server. And this may create a different port here. So 5173 in my example. So you have a fully fledged dev environment just by this one task. Then we have the build SBT, which contains all the library definitions for multiple projects or multiple modules in this project. So we have a client, a server, and a shared project. Because Scala is a full stack language, you can create a shared project where you can share data structures or definitions that are both useful for the backend and for the frontend. And I'm going to demonstrate them shortly. So this contains all the definitions and the project structure that you need. And in general, all that you should need for a full stack project is a client, a server, and a shared project. Now, under shared, you have 3 submodules here for JavaScript, for JVM, and for cross-compilation. And if you want to compile a certain definition just for JavaScript or just for the JVM, you would put them here. So under JS, you would have source, main, Scala, and whatever. Under JVM, similarly. Or if you want to cross-compile for both, you would store them here under source, main, Scala, and then you have your own package, com, example, whatever. And here, you'd have your regular Scala code. For example, you would define your case class. So for example, you have the case class person with a name, email, password confirmation, age, and whatever data this case class contains with your methods and everything else. This case class will be available for both the client, which is Scala.js, and the server, which is going to be a JVM backend. So the case class definition will be available for both. That's because the client and the server both depend on this shared project. So if you change anything here, this will trigger the recompilation of both the client and the server. And this is pretty cool because you can modify your full-blown or full-stack application just by defining your own domain. So we have domains for the usable data. We also have a domain for errors if you have your own error model. So we have application exceptions for various use cases. We also have HTTP errors, and this is particularly useful for the server and for the front end to interpret HTTP errors and display the appropriate error messages as regular front end pieces like divs and whatever. And under domain, we have all these definitions. Then we also have HTTP definitions, all the endpoints. So endpoints are useful because the backend will implement them. So these are just the endpoint descriptions, but the front end will be able to use these endpoints and invoke them like functions. Endpoints are defined with the Taper library. So Taper is from SDP. This is one of the battle-tested HTTP libraries that are both useful for the backend and on the front end. And we have the base endpoint, which contain some common attributes. For example, everybody errors out with the status code and a string, which we will encode and decode to this HTTP error data type. And we use this base endpoint as a root type for all the endpoints that we need. For example, the person endpoint is far more interesting. So the person endpoint extends this base endpoint, and everything that we defined here, for example, the create endpoint, is just a description of how the HTTP endpoint would look like. So for example, this is going to be a post endpoint. So this is going to be a post at /person. Or if we take a look at base endpoint, we have prepend in API, which means that the backend is going to be API/person. So post at /API/person. And we then describe the JSON body person with a description and an example. This is for the Swagger API descriptor. So in JSON body person is going to take a JSON object that is going to contain all the fields that a person case class also contains. So this is going to parse that JSON into a person case class automatically. Out a JSON body user. So this is going to give us back a JSON body of type user. So this is going to be a user, and the input is going to be a person with all their respective fields. Description, create person. All these descriptions and examples are useful for the Swagger API descriptor, which is particularly useful if you're working in a team and the team doesn't have context over what you're doing here. So you can create various numbers of endpoints here. We have login, profile, and everything that you might be interested in. So person endpoint. Okay. Now you can define endpoints for various use cases. So persons or authorizations or pets or AI integrations or anything else, you can define them here and they will be available for the front end and for the back end. So that's the shared project. In shared, we usually store the domain model and the endpoints that are going to be visible to both. Let's go to server. So under server, we have source main Scala. We have a bunch of layers here under the server module. So the server module is layered in repositories, services, and then HTTP implementations. So I'm going to go bottom up. So the bottommost layer is the repositories layer, which is going to contain some functionality that integrates with the database. So the persistence layer is going to be implemented with Quill, which is one of the ZIO libraries for interacting with the database. And I'm going to give you an example here for the user repository. So the user repository is something that abstracts away the interaction with the database by these methods. So the trait user repository is going to create some methods that are going to return effectful instances. So these are going to return effects that, when successful, is going to give you back some useful case classes that you can parse and then you can use as business logic one layer up. So for example, this user repository has create, get by ID, find by email, update, delete, the regular CRUD. So create, read, update, delete sets of functionalities. So CRUD. And this user repository is usually implemented right below. So we have a class that we called user repository live, and we take a bunch of dependencies here in the constructor arguments. And we use Quill to implement all these functionalities. For example, let's look at get by ID. I'm going to isolate it with some spaces here. So the get by ID takes a parameter of type long, and this returns a ZIO task where the value, the useful value, is option user entity. So we call run query user entity. This is a macro generator that turns the Scala code into a SQL command that is going to run on the database. So for example, in this case, we have query user entity filter on this ID is equal to ID. So this is going to turn into the SQL command select star from, and then we're going to pass the given value, which is the schema meta of this new user entity, which is going to essentially describe the table that we're going to interact with. So this is going to be the users table. So select star from users, where ID is equal to the parameter ID long, which is what we're doing here with lift. So I'm going to have the ID that we're going to pass as argument. And this is going to give me back a task, a ZIO task of list of user entity. That's because we have query of type user entity. So the auto mapping happens on the Quill side automatically. So we don't have to care about that mapping protocol. So we have task list user entity, and we map that particular effect to return just one. So I'm going to return a task of option of user entity. And this is just one example. All the run commands on all the queries here on Quill turn into select queries or update queries or delete queries or any sort of SQL queries that we're going to run on the database. And this is the same for all the methods like create or get by ID or find by email or update. Let's look at update, for example. So in order to update an existing ID in the table, we first need to find it, which is why we call get by ID first. And then in a for comprehension, we take that particular entity, and then we're going to run a query, filter, and then update value. And the update value returns or transforms into a SQL update query that is going to run on the database. And this is the same for all the queries that we run in this repository. So pretty much the same pattern all over the place. And this is user repository. We also have, I think we have another one with pets repository, which essentially does exactly the same thing with get cat by ID, get dog by ID, delete, and anything else. So the repository is essentially an abstraction over the database with some methods that are in the CRUD shape. And most of these CRUD methods return ZIO effects. And as I'm pretty sure you know, tasks are ZIO effects that can fail with the throwable type. So tasks are effects that take no requirements, and they can fail with throwable. And then we have repository and transaction support. These are auxiliary types that help us with the code. So we have this TX auxiliary function and the repository object, which contains some layers. More on that a little bit later. So on top of repositories, we have the service layer. So under service, we have a bunch of business logic pieces that compose the core of the application. So for example, we have the person service. So the person service, let me collapse this code. The person service also contains some methods. So I want you to take a look at the person service trait. So we have the act of registering, the act of logging in, the act of getting this person's profile. This may or may not have something to do with a database. And for example, in the case of get profile, we do, which is why we sometimes refer to the repository to be able to obtain that sort of data and service that to the HTTP layer or to the business layer to perform some useful actions. So for example, this person service live takes all these repositories as arguments, and we also have another service that is used for authorization. We have the GWT, more on that a little bit later. So if you want to, for example, register a person in the database, we have all the sort of mini programs that we run for this particular action. So the register does a bunch of debugging. We try to parse the pet entity, and then we defer to the user repository to create this particular user. So we're using the layer one level down, and then we can catch some errors, and then we can return a user. And this for comprehension describes this entire action as one program. So this register is usually a ZIO effect that is composed of other smaller ZIO effects that are probably going to delegate to the layers below. And this is very similar for all the other applications. So for example, the act of logging in asks the user repository for the user on this email. And if this user exists, then I'm going to validate this user's password. And after the password has been validated, I'm going to return that particular user. So as you can tell, the service layer is described by actions that the application has to perform. And these actions are grouped into various purposes, and each purpose describes a service. So for example, this person's service has the purpose of managing people in the application. We have other kinds of services, for example, the GWT service, which has the purpose to validate user tokens or to create new user tokens to authorize users to perform certain actions in the application. The Flyway service has the purpose of running database migrations, and so on and so forth. So various services describe various purposes that the application has to fulfill. Now, besides repositories and service, which is essentially the core of the application, we have the HTTP layer, which contains controllers. And the controllers are essentially the implementations of the endpoint definitions that we had under the shared package. So under the shared package, if you remember, we had the HTTP endpoint definitions. And here under server, we have the endpoint implementations under the HTTP controllers package. So for example, here under person controller, we have the implementation of, for example, the create endpoint. So the create endpoint is person endpoint.create, and then we have .zServerLogic, and zServerLogic essentially returns an effect that, when successful, is going to return the payload that this create endpoint will return back as an HTTP payload. So we have personService.register. Essentially what this means is that when you call the HTTP endpoint, the register function from the person service is going to be called, and its return value is going to be returned as the HTTP response as JSON. And the general pattern of an endpoint implementation is probably going to delegate to one or more services downstream. So for example, the login endpoint. First of all, it asks the person service to validate the login with the username and password. And if the validation has been successful, then I'm going to invoke another service to create a GWT token that I'm going to surface as an HTTP payload as the token that I'm going to return from this for comprehension. And similarly for all the other endpoints. Now, if you're curious how the login functionality happens, how the hashing of passwords happens, and how the GWT happens, we have under the service layer, we have some auxiliary data types, which is the hasher, which helps hash the passwords into a format that I chose here under the ZIO Rite of Passage course. Obviously, you can pick your own format, but this essentially does a hashing with a bunch of parts that you can then recover if you have the right password. And the JWT service uses the auth0 JWT library and wraps some of those functionalities in ZIO effects. For example, the ability to create a token, verify a token, essentially calls some functionality of the JWT library to create a JWT item and return that as a user token. Or the ability to verify a token is essentially going to delegate to that library. So I'm basically doing a ZIO wrapper over the auth0 JWT library to be able to get values into my preferred structure. Okay, so the hasher and JWT service deal with authentication and authorization. Okay, and obviously by the JWT service, you can also validate claims in the JWT. You can also implement role-based access control and the more complex functionality if you require. Okay, so we have repositories, services, and HTTP controllers. How do you tie them all together into a coherent application? Well, all these controllers expose one or more endpoints. For example, the person controller exposes multiple endpoints specifically dedicated to managing people. If you want to manipulate them and combine them into a single list, we have this HTTP API wrapper. So the object HTTP API has a bunch of controllers that is going to aggregate under a single list. So we have gather routes, make controllers, and some auxiliary functions that is going to return all the endpoints as a single ZIO effect. So this is going to return a ZIO effect that is going to give us back a list of all the server endpoints, given that we satisfy all the right requirements. And all the requirements consist of the dependencies that all of the controllers will take as constructor arguments. In this case, we have the person service and the JWT service as constructor arguments. Therefore, the ZIO effect requires that these be present when we instantiate and run this ZIO effect. Speaking of which, the main application is going to be here under the HTTP server, where we tie everything together. So the HTTP server is the main application, which is the ZIO app default, and the ZIO app default has one method called run. Now, the run method essentially runs a single ZIO effect called program. If we take a look at the program, it runs the run migrations function, and the run migrations function refers to the flyway service and does a bunch of logging here. So run migrations is a single ZIO effect that runs the flyway service's run migrations function. So in order for this sucker to work, we need the flyway service as dependency. So that's one thing. And then we start the server, and the server program takes all the endpoints, all the endpoint definitions that we just outlined earlier, like 1 minute ago. And then we have server.serve, and we build all the routes as HTTP endpoints here with ZIO HTTP. So the taper library that we use to declare the endpoints is not necessarily tied to a particular backend, so we can choose other backends like Play Framework or Akka or Peko HTTP or HTTP4S, or in this case, ZIO HTTP. So this is the place where we inject the actual implementation of the HTTP endpoints. So we have ZIO HTTP interpreter to HTTP, and then we have all the endpoint definitions, including the metrics endpoint for Prometheus. We have WebJar API endpoints, and then the documentation endpoints with Swagger, which will use all the endpoint descriptions that we had earlier from Taper. So this is the place where we have ZIO HTTP as the actual server implementation that will serve all these endpoints. So server is going to also be a ZIO effect. Now, the program is going to be a combination of all these effects, which will take all their dependencies. And if those dependencies have dependencies, then those dependencies will be required as well. Which is why, at the very end of the world, in the run method, we say program.provide, and then we provide all the layers necessary to build the dependencies or the dependency graph that the program needs to run. Now, I've talked about ZIO layers and dependency injection on another video here on the Rock the JVM channel, and also at length in the ZIO course if you're interested in checking that out. But essentially what this does is that we provide ZIO layers, and by macros, or by virtue of macros, the graph, the dependency graph, is automatically parsed and the right instance is put into the right place by magic. So for example, if I go to my HTTP API, this endpoint ZIO, which is an effect that is required for the server to run, takes as constructor arguments or as requirement person service and JWT service, which is why we need a layer of type person service and a layer of type JWT service for this effect to be able to run. Now, here under HTTP service, we have this exact layer. We have a person service live.layer and JWT service live.configured layer. Now, the way that these layers are being built, if we go to person service, is that as a companion object to the class that takes all these constructor arguments, at the very bottom, we have a companion object, which we call layer. And this is going to be a ZIO layer that takes several requirements and returns back the layer of the type that we are interested in, which is why ZIO is able to figure out all the dependency graphs, because at the type level, all of these are mentioned here at or in the generic type parameter list. And by zlayer.derive, a little bit of macro magic takes a look at this person service live class definition at its constructor shape, and all of these are being fetched as constructor arguments or as requirements for the ZIO layer to be instantiated. And at the end of the world, we can pass them in any order that we want, and the provide method will take care to figure out in which place in the dependency graph each layer needs to sit. So this is the place in the backend where every piece is being put into place, and we turn this into a coherent JVM application. So this is what you're seeing here when we have the server run task here. On the right-hand side, we have the server logs from the server backend. Okay, cool. So let me collapse that and let us move to the front end. So we have the shared project, the server project, and then the client. Now, the client is built with a bunch of components. First, we have Scala.js, which is able to compile Scala to a regular JavaScript here under target. So under target Scala 351, we have, under client fast-opt, we have a bunch of JavaScripts that Scala.js created for us. And the main.js is going to be the final JavaScript that is going to be run from the index.html. So here under index.html, if you take a look at here where we have the body, we have script type module source equals main.js. So this JavaScript is going to be run here from the index.html. So from the front-end server, if you take a look at npm dev, where was that? If you take a look at where this serves the front end at localhost 5173, it actually serves this index.html. And when this index.html is loaded, it will run the main.js, which is compiled by Scala.js. So if I change something in the code, then the main.js will be recompiled and Vite will reserve your application. That's the general flow, the general development flow. Now, this particular front-end implementation can also interact with JavaScript or TypeScript libraries. Much like the Scala JVM can interact with Java libraries, Scala.js can interact with JavaScript or TypeScript libraries via a little tool called Scalably Typed. Now, in order for Scalably Typed to work, you need to install all the npm dependencies declared here under package.json. We don't have that many dependencies here. We have Vite, and we also need TypeScript. These are all defined here under package.json. For example, TypeScript is declared here under dev dependencies. All right, now before you run this particular web application, you need npm install, which at the first launch of this particular project has already been run as a task. So you don't really need to care about that. So essentially, all you need to care about is your own source main Scala, whatever, here under app. And here under main Scala, we have what's going to be rendered on the page for the first time. And the result of the main function is going to be this render function that is called from the Laminar library. I'm pretty sure you've learned about Laminar. This is a functional reactive programming library for Scala.js frontends. And what's going to happen here is that this render function will put this div inside the app div in index.html. So if we go to index.html, we have at the moment an empty div, but the main.js is going to render something inside this div. So this is going to be your content. So Scala.js is going to render the valuable content under this div called app. So this is what's going to happen as a result. Now, the logic behind how that div is going to look like and how it's going to work is described by this my_app container, which is going to contain a piece of logic and all the components that this div is going to contain. Now, if this is your first time with Laminar, it might seem a little confusing or a little unintuitive. I spent more than 10 hours in the ZIO Rite of Passage just talking about the front end. So I'm going to go through some of these components and try to explain how they work. So for example, here under header, what does this header contain? The header apply method is going to return this div. This div is going to return a visual HTML content. Now, currently, this apply method or this div contains an existing component called a shell bar, and this can have a bunch of properties that are being set with this little := attribute. So this is an actual method under Laminar. And then these arrows describe interactions between visual components and data reactive variables. And in Laminar, reactive variables are of 4 types. One we call event streams. And event streams are readable pieces of data of a certain type, so event stream of type A. And this emits elements of type A. And if you say that a piece of content subscribes to an event stream, now, this particular content is going to re-render itself if this event stream renders a different value. So if this event stream currently emitted the value Daniel, then this content will take the value Daniel. If this event stream suddenly emits a new value, like Alice, then the content will be automatically re-rendered with the new value. So if you say content left arrow event stream, then the automatic re-rendering happens when event stream emits a new element. So we have event stream of type A. Then we have event bus of type A. Now, where event streams were readable, event bus are writable. So you can write elements of type A. And you can say event bus.events to be able to read whatever event has been written on that particular event bus. So in this case, we have open popover bus events, and then we have some combinator with another event bus.events. So we are merging 2 event streams, and whichever event comes first is going to set the state of this particular popover.open attribute. So you can use event bus to write elements of type A and then read them on the other side when you want to render something on the screen. So we have the emission of elements and the writing of elements. Then we have signal. And signal is an event stream plus a state, so a current value, whereas event streams and event buses don't have the concept of a current value. So you can read the current value of a signal. And then we have a var, which is a read-write reactive variable. And with just these 4 concepts, you can combine them in any number of ways, and you can create arbitrarily complex front ends. So if we take a look at this particular example, we have underscore events on profile clip mapped to true. So this is going to be a source of events, a source of clicks that are mapping to the value true. So whenever I click on the profile page on this profile thing, like this sucker, emits the value true. So the true value is being emitted over and over again to this open popover bus. And the open popover bus is then being read on the other side, and the popover's open attribute is being determined based on the event from the open popover bus. And this frontend has a bunch of components that contain some reactive variables. I'm not going to describe all of them. So the header contains some user state, for example, logged in and not logged in states, as well as various other components that you can refer from the frontend. Okay. Now, very importantly, the frontend must have the ability to invoke backend endpoints. For example, this login handler can call a login endpoint. So person endpoint.login with credentials.now. This is a reactive variable that you can inspect state. So person endpoint.login .map. So for example, in this case, we have a ZIO effect. because person endpoint.login is going to be a function that returns a task user, if you remember. So we have access to the endpoint definition from the shared package. And then we can map ZIO effects as we see fit in Scala.js. So again, this is a ZIO effect. And then we have some pretty magical functionality that we describe at length in the ZIO Rite of Passage course, that when the ZIO effect is being evaluated, we can push its value into an event bus that we can use for reactive rendering of UI components. Now, we spent a lot of time on this little sucker, and we created a lot of magic in the ZIO Rite of Passage application to be able to use this particular function so nicely. Now, Olivier took the time to abstract this away into his own library called ZIO Laminar Tapir, and the emit2 function, you can find that in his library so that you don't have to write this over and over again. So all in all, you can define various UI components with reactive variables, and we can also define routers or reactive variables based on browser actions. So this is one last thing that I wanted to demonstrate here. So the router function has a routes invocation from a library called FrontRoute by the same author that created Laminar. This is a utility library that listens to browser effects and browser actions, including the backward and forward actions from the browser buttons. So we have a routes function that takes an API that's very similar to ZIO HTTP, if you remember that. So this is going to give us the matching of paths or the matching of URLs to be able to render the appropriate components or the appropriate pages based on those paths. And whenever you change the URL, or whenever you click a link, or whenever you click the backward or forward buttons in the browser, this little routes function is going to re-render what is going to be shown on the screen by rematching the URL against all these possibilities. Oh, one other thing. I wanted to demonstrate the scalably typed tool for interacting with existing JavaScript or TypeScript libraries. So if you go to demos/scalably typed, under the application. So if I go to localhost/demos scalably typed, we can take a look at some JavaScript or TypeScript components. So obviously you can add points, or you can add random properties here, and you can get a chart where you can compare and so on and so forth. This is just an example of a library or of a web component that you can integrate into Scala.js. And I want to show you how you can do that. So I'm going to go to scalably typed demo page, where we have a bunch of reactive variables that will describe this little mini web application with all these lists and whatever. So these are described in the code. So for example, we have the data var, all the values, and so on and so forth that we can add whenever we click one of these buttons. Now, the interesting bit is obviously the chart from the chart.js library. And the chart.js library is being rendered here at the bottom. So when we have the render data graph, we have the canvas tag, and then we have data from the chart.js library. So we have the chart configuration, chart type, chart data, chart options, and everything that is being described in the JavaScript library. And we have some JavaScript converters from scalably typed that we can use in a type-safe way here under Scala.js. So there you have it, folks, an example of a ZIO full-stack web application in Scala 3 with the ZIO stack and Laminar on the front end. I hope you enjoyed this video and Olivier's library and demonstration. If you like this video, go ahead and click the like button and subscribe for me to the Rock the JVM channel, and check out my website at rockthejvm.com. I have literally hundreds of hours of pretty much everything in the Scala ecosystem that you may ever want to watch. So until next time, folks, this is Daniel signing off.